All right, this is Mr. McCord's ICP class, Unit 5, Lab number 2. We're going to be looking at modeling covalent compounds. So in class, we have some atoms of models like snatoms, and you can also get other ones that have little wooden pieces with springs and sticks. But we don't just have to model chemicals physically with little spheres and magnets and sticks and springs. We can also just find it online for free. So the website we are going to use is molview.org. So MOLVIEW and then .org. You'll first see this page here. You can just hit close. Right? And then you can look up basically any chemical that you want. The first one they show you is caffeine. All right, so if you've ever wondered what caffeine looks like, you've got atoms that are color-coded on the left and right, so you can kind of compare the drawn-out structure to what it actually looks like in 3D. So I can spin this around and see what this guy looks like. All right. We've got black representing, or I guess kind of dark gray, representing carbon, white or a light gray representing hydrogen, blue is for nitrogen, and then red is for oxygen. The sticks in between our atoms, like this guy right here, represents a covalent bond. Okay, so this is where we are sharing electrons rather than doing a give and take. Figuring out the structure of a covalent compound is a lot tougher because there are a lot more options for sharing electrons between atoms than giving and taking. So for now, we're just looking at how we can figure out what something is made of and to kind of draw the structure, give it a formula, give it a name. Okay, all we have to do is go up to our search bar and we can type in the name of a chemical and see what comes up. We can also type in formulas for chemicals too, although sometimes it doesn't always work. So it's good to have kind of either option. Now, also, we can look up the common name of a chemical, something that you would find, either in a textbook or on the internet or on the side of a bottle or a box or something like that. So we're going to show a couple examples of things you might kind of run into that are made of covalent bonds, stuck together by covalent bonds. So let's go through some examples. Okay, so we've got to look up a couple examples of chemicals. The first two we're going to look at are common cleaning supplies. So the first one is going to be acetic acid. So I'm just going to type in acetic acid up here. It doesn't have to be capitalized. You can do it lowercase, acetic acid. Just hit enter in my little search bar. And I get a chemical that looks like this. So again, I've got carbon atoms, I've got hydrogen atoms, I've got oxygen atoms, and each stick kind of connecting them represents a covalent bond. Over on the right, I can spin this guy around to see the full 3D shape. I can zoom in on it so I can get a closer look. Spin around more. I can zoom back out if I need to. Okay, we can also change the way we view this. So this is called a ball and stick model for obvious reasons. But if you go to tools, model. There we go, model. You can do ball and stick, you can do stick. Sometimes you'll see models like the snatoms I have in my class that look like this, where they're kind of blown up in spheres. So this is called a space filling model. So we're seeing kind of all the way out to the electron cloud. With the ball and stick, we kind of shrink it in a little bit so we can see how atoms connect to each other. This gets a little crowded. But this is a kind of a better representation of how the electron clouds of atoms overlap as they share electrons. Okay, so for our acetic acid, we could write a formula for this by counting up how many C's and H's and O's there are here. Let's do another one. Let's do sulfuric acid. Sulfuric acid. And if you're not really sure on the spelling, sometimes they'll give you suggestions. So if I can type in sulfuric, there it is, sulfuric acid. Enter. And there it is. Okay, I'm going to switch it back to the ball and stick model so I can kind of better see this. All right, so there's my molecule. So I could, again, sketch this out using the structure on the left. That way I don't have to try and build it from scratch. And I can also use this to figure out the formula. Finally, you can try and make a model in real life. You can try and build a physical model that matches what you see on the right side here to see if you get the same 3D arrangement where stuff is sticking out in weird ways, as long as we got the right pieces for those kinds of models. Okay, so again, you kind of H's, S's, and O's, and you're good to go. Next up, we're going to look at two common components of air. All right, it's going to be dinitrogen is the first one. It's pretty simple. Just two atoms of nitrogen stuck together. We've got three covalent bonds in there. That's what those three sticks are. All right, so they are pretty tightly held together. Okay, this makes up about 78% of the air that you breathe, but the other important part is dioxygen. Dioxygen looks like this, which is two atoms of oxygen stuck together. So we can make formulas for those too. Spin it around. Right. We're going to look next at some common components of natural gas. So if you have a tank for your gas grill, or if we're using Bunsen burners in the lab, or if you've got gas heating in your house, these two chemicals we're going to look at probably make up most of what that gas is, along with a couple other impurities here and there. So the first one we're going to look at is propane, propane tank. And this is what propane looks like. Spin that around there. Again, we got the structure on the left. I can count up C's and H's, and I can figure out the formula. And since there are only two elements here, I can also make a name for this covalent compound. So based on how many C's there are, I can use a prefix. Like I've got three of them here, so maybe tri would be good. I've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, so I could use the prefix octa for the number of hydrogens. And then we usually pick kind of the middle atom to go first. So carbon would be first. Hydrogen's got to have the end chopped off to be IDE. And then I use those prefixes. So like tri, I'm going to have my carbon piece. I'm going to have my octa, and then my hydrogen chop off the end to make it hydride. Now also on your screen, you might have something kind of go wonky like this, where you just have like some lines. Right? This is a simplified structure for really big molecules, like the capping we saw earlier. Sometimes it's easier to kind of simplify it like this. But for our purposes, we want to see all those little atoms in there. We want to see all the C's and H's and stuff. So if you get something like this that's just lines, it doesn't have letters, go up to this top button here. It says toggle skeletal formula. All right, it's a little C and H thing. So if you're missing C's and H, click that to get your C's and H's back. And there you go. The other component of natural gas that we deal with most is methane. Like this, a little simpler version. Spin that around. It's kind of like a little tripod there. And again, if your H's are missing, you can just click on that button there and it'll show them for you. Right. Now also in chemistry, we sometimes will dissolve a substance in something else. We call the substances that do the dissolving solvents. So solvents dissolve things. One of them that we look at is called hexane. It looks like this. It's a string of 6 carbons kind of bonded to each other. You've got a bunch of hydrogens hanging off of those. So this is what our molecule would look like. All right, again, we could count up C's and H's and then make a formula and a name for this. All right, and then the other solvent we're going to look at is tetrachloromethane. That's a long one, tetrachloromethane. And again, if you mess up the spelling, you might be able to have a suggestion that you can follow. There's this guy. So C's and Cl's in this guy. We've got 1 carbon. We've got 4 chlorine, so we can make a formula and a name for that. The next one we're going to look at is ammonia. We're now moving into some common components that smell bad. If you've ever had sewer gas come up from your sink or your plumbing, or if you've just had like kind of a rotten smell coming from the trash, you might be smelling these two chemicals. So the first one is ammonia. Ironically enough, it's not just in dirty stuff, it's also in glass cleaner. So if you ever kind of get a bitter smell from your glass cleaner, you might be smelling ammonia. You might also just buy it. You might see it as ammonia if it's not a complicated mixture like Windex or something. So this is our ammonia here. One nitrogen atom and 3 hydrogen atoms covalently bonded. So it's got kind of a nasty bitter smell. And then the other one we're going to look at is called sulfane, S-U-L-F-A-N-E. Looks like this, nice and simple. Just 1 sulfur atom and 2 hydrogen atoms. So we can get formulas and names for those. In the case of sulfane, we're going to put hydrogen first in the name rather than sulfur. Typically, again, it's usually the middle guy, so you'd think sulfur would go first, but we're going to use hydrogen first. Now, it doesn't totally matter. You could probably find what you need if you put sulfur first in the name, but putting hydrogen first is going to be the more common version of the name. So if you're checking your work, it's going to be the easier one to find it like that. All right. These last ones are going to be things you can find in gasoline. One of them you might see on the pump when you go, when you check like which version of gasoline you're going to get. You might see the octane rating. We're going to look up octane. Right, so if you are big on cars, you might know about how the concentration of octane in your gasoline affects kind of how smoothly your engine runs and the knocking and stuff. We've got a bunch of C's, we got a bunch of H's, and we could use a number of prefixes for our C's and H's. So similar to the hexane one we saw earlier, but we're going to use different prefixes to say there's a different number of C's and H's in here. Okay, and finally, look at benzene. It's kind of a fun word to say. A lot of stuff with C's and H's here, right? And this one's kind of in a ring. This is a cool one. I always like this guy. This is our benzene. It's flat, right? And it's got 6 C's and it's got 6 H's. So we can figure out a formula and a name for this guy too. Right? Now, MolView is a great program because you can look up all kinds of chemicals. If you notice, as I just type stuff in, you get all kinds of stuff down here. So, for instance, you can look up, like we had before, caffeine, and you can get the structure for what that chemical looks like. You can spin it around and get in close to it. You could look up, let's try acetaminophen. So this would be something you could get like at a pharmacy. Just an over-the-counter like painkiller or something. That, and there's our acetaminophen. What would be another fun one to look up? We could look up. Let's see if we can do like vitamin C. Oh no, that's actually, I got it. Citric acid. This is something that's in a lot of fruits and fruity drinks like apple juice and orange juice that gives it kind of that tangy flavor. This is your citric acid here. Oh, this is kind of a fun one. It's all kind of crooked and turned around and stuff. So there's your citric acid. Pretty neat. You get some really complicated ones on here. Let's do one more. Let's do ethylene glycol. Since we were talking about cars earlier, ethylene glycol is one of the chemicals you can use for coolant. They're an antifreeze. This little guy is our antifreeze molecule, typically. All right. So I encourage you to check the program out, see what you can find kind of in the other settings, kind of mess with it. You get to like bigger molecules called proteins that you might find in the body and other organic or biological stuff. It's just kind of a fun program to mess around with and try out.